Hello everyone. So today we are going to learn about a very fascinating topic in physics, which is we are trying to understand why exactly planets move the way they do. Uh, for millennia, it took a very much time for astronomers and physicists to understand why the planets follow the particular path in our night sky. Why at one moment we see a planet in one particular constellation, while in another season we see the planet in another direction. Why the planet moves the way it do. In order to understand that, we have to go back in the history. Back in early 1600, astronomers have a detailed record of how planets move, and one of the prominent of all the astronomers was Tycho Brahe. He has this very huge and very sophisticated laboratory or observatory, per se, where he calculated the very precise data of how planets move for a long time. And after Tycho, what Kepler did, the Kepler came into a picture. And Kepler tried to use that particular data in order to analyze, in order to deduce the laws from that particular data and give us the laws of motion. And based on that data and based on the laws, we understood, okay, what this is the reason why planets move around our sun in the particular way. Now we are trying to understand those laws in a very precise manner. In order to do that, I will go to widescreen. We are going to understand Kepler's laws of planetary motion. Now, basically, in order to understand the Kepler's law of planetary motion, we have to understand how exactly planets revolve around our sun. So, before Kepler, we used to believe that this is sun and planets revolve around it in a circular orbit. Well, let me draw a circle precisely. The sun and planets revolve around our sun in a circular orbit. So we used to believe that planets must revolve around our sun in a regular orbit, from Mercury to Venus to Mars to Earth to every planet. However, when we observe and when we collected data, the data has some problem because data was predicting something else. It was not correctly explaining that planets might revolve around our sun in a circular orbit. Then there must be something else that this idea might be wrong. But then what could be right? And that's when Kepler came into the picture. Kepler realized that no, planets do not revolve around our sun in an elliptical orbit. No, in a circular orbit. Rather, they revolve around our sun. Wrong. So it will be not a perfect, but you can get the idea. So this is an ellipse. Ellipse, one of the speciality of ellipses, as we learn in mathematics, is that ellipse has a two focus. This is focus one, and this is focus two. So what Kepler deduced that no, planets do not revolve around the sun in a circular orbit. Rather, they revolve around the sun in an elliptical orbit, where sun is at one of the focus. So sun is here. Sun is at one of the focus. And this is, let's say, Earth, and it will revolve around in this elliptical orbit where sun will be at one of the focus, and not just earth but every single planet which we found in our solar system, in Neptune and Uranus, all revolve around around the sun in an elliptical orbit where the sun is at one of the focus. It could be at this or it could be at this focus, but for our understanding we assume it to be at this focus. So from that law, we understand one very crucial idea that, let's say, Earth is here, it would have a different distance from Sun. When Earth will be at this point, it will be going to have a different distance from Sun. When Earth will be here, the distance will be different. And Kepler realized that, okay, then it means that distances from our Sun of one particular planet is different, not just for different planets, but for the single planet, it will be different. And based on that, Kepler came up with a second law.